Today's topic about shortest path. So, at first introduction, Dijkstra's algorithm finds the shortest path between a given node and all other nodes in a graph. This algorithm uses the weights of the edge to find the paths that minimize the total distance between the source node and all other nodes. The main part in the Dijkstra's algorithm is that in all weights, it will use just positive values. And depending on how the algorithm is implemented and what data structure uses, the time complexity is typically O E log V. So E is edges and the V vertices, which is computed against other shortest path algorithms. So here, a simple graph about Dijkstra's algorithm, and let's consider that our first value will be 0, and from 0 it will go to 1. So at 0 so it will go to 1, and if first index will be 1, so distance value will be a weight of this vertex, which equal to 4. Like this, it gives a value 4, and after this, we'll go to another value, another age of 0, and it will be 2. Uh, so this for 2 will be 1. Next value will be 1 4, then 2 and 1. So in the bottom here like table, so 0 0 it's an index, and this and 1, and then will be 4, then 2, and there will be 1, and after this when all edges of 0 is visited, so we're going to 1, and first we are going to visit 3. It will be 3 because it gets value from second one, and it 1, and 1 cost 1 plus 2 will be 3, and the 3 it's a new, and this for 1. After this it will go to 3, and check values of 3. So the shortest path will be like this: 0 0 1 3 2 1 3 4, and 4 7. Here see the code. So run Dijkstra's algorithm that returns an array that contains the shortest distance to every node from the start node S. We have 3 values. So G is the adjacency list of weight graph, and it says the number of nodes in the graph, and the S the index of the starting node. So function Dijkstra and G and S. And then we have a Boolean array V's, which has values like false. So false is not visited. Then it will have this, and then inside this it's positive infinity values. The first value by default will be 0. The primary key, which is empty priority queue. Then we are going to insert to our primary key new values. After this, we will have loop. So while our primary key is empty, it's not empty. At first, we pull index and the minimum value. Then, if it's visited, we're going to give value true. And after this, if this index less than our minimum value, we are going to skip it and not consider for this item. Then loop. So for every age which has a item of this index, if it's already visited, we're going to skip it and create new distance which m equals to alt distance plus cos of h. Then we are going to give for all this old distance new value and insert it. In Java example, I have a class dighistory example, and the total vertex will be equal to 9. And then here is a function int which return minimum index. So m is equal to a maximum value of integer, and the m index will equals to minus 1. So here loop, so start from 0 to total vertex, and in this loop if this set vertex is not visited, and in this distance if this value okay, if this value less than maximum value of integer, we are going to create a minimum index. And the method for display the distance array. Okay, it just will print solution. Method that does the implementations of dighistory short path algorithm for a graph that's being represented using the adjacency matrix representation. So here adjacency matrix and the source value which has a length of total vertex. So set will be true if vertex j is included in the shortest path 3, or the shortest distance from the source s to j is finalized. Okay, here Boolean matrix, and for give true or not if it's included in the path. Initializing that all of the distance is infinite, and set for this item a false value. Distance from the source vertex to itself is always 0, and again loop for compute the shortest path from all given vertices. And here we are going to call minimum distance function for choose a minimum vertex from the set of vertices. If it's chosen, that we are going to mark that it's true, and then here we start our loop, and update distance item if and only if it's not in the